I might as well take a minute or two to put you onto some game. You got a boy like him, a man like me, and that's just not the same.
Hello and welcome to the video on the chain rule. Okay, so the chain rule is going to be used for differentiating in particular composite functions. Okay, so for differentiating composite functions, and I'll give you a refresher on composite functions. So what are composite functions? That would be like f of g of x. Okay, this is the same thing as saying f parentheses g of x. Okay, so basically when a function is inside of another function, or when a function, this outside one, so outside function, contains another inside function. Okay, so here's our inside function. Alright, so what is the chain rule? So let's go over that. So our chain rule is going to be that if both f and g are differentiable functions, so are differentiable functions, then we have that f of g of x is differentiable, and furthermore, and f of g of x, so all of this, taking the first derivative of all of that, is going to equal f prime of g of x times g prime of x. Okay, so this last line here, I'll write that at the top of the next slide, and I'll go more in detail about what it means. Okay, so we're taking the derivative of f of g of x. Okay, so again, we're going to differentiate the outside function first. So what we're going to do is start from the outside. So we're going to work from the outside in. So we're going to write that down. We're going to differentiate that outside function, which is our f, right? And then we're going to keep the inside the same. So whatever's on the inside, that's just going to stay the same, the original function. And then we're going to consider the inside, and we're going to take the derivative of that one. So g prime of x. Okay? So we can't forget about that inside one. So we're going to take derivative of the outside, keep the inside the same, and then multiply times the derivative of the inside. Okay? So again, we're working from the outside in. So this is what we're going to follow, the rule that we're going to follow here. Alright, so let's do an example of this. So I'll rewrite it here, f of g of x, and then prime is equal to f prime of g of x times g prime of x. Okay, so that's just a note of the chain rule. Our problem is going to be to calculate, we're going to calculate y prime for the given y is equal to sine of, not x anymore, but x to the third power. Okay, so let's identify what is our outside function, our f, and what is our inside function, g. Okay, so in our y we have this sine of something, so this is going to be our outside function, the sine of something. Okay, so this is our outside, and I'll call it f, okay? And our inside function, this is our inside g. So f is going to be f of g of x is equal to sine of x to the third. Okay, so let's say we want to find the derivative of this, so y prime is going to be equal to f prime of g of x times that g prime of x. So what is this going to equal? We have that y prime is going to equal, so the derivative of the outside function first. So derivative of sine is a cosine, a positive cosine, right? Cosine, and then this g of x means you keep whatever was the inside function the same. Okay, so we're just going to rewrite that x to the third in there. Okay, so this is that part, right? We just wrote that down, and now we're going to deal with the inside part. So times g prime of x and g of x. So g of x is equal to x to the third. Okay, so g prime of x is going to be a 3x squared according to the power rule. Okay, so now here we basically found our answer, and I'll just rewrite it in a more nicer form. So 3x squared times cosine of x to the third. That's going to be our answer. Okay, so here we use the chain rule to differentiate the outside function first and then the inside function. Alright, let's do another example of the chain rule. So we're going to calculate the derivative of y is equal to the cube root of x to the third plus 2. Okay, so this one, half of it of applying the chain rule is first of all figuring out what is our outside function and then what is our inside function. And then you can just basically apply the formula. So the outside function, let's see, it's not really super recognizable right now, but I'll just rewrite it in this form instead. X to the third plus 2, quantity to the 1/3 power, okay? 1/3 power is the same thing as the third root, okay, or the cube root. Okay, so now we can see anything inside the parentheses is going to be our inside function. So this is our g of x. And the outside function is going to be this whole something to the 1/3 power. So this 1/3, raising something to the 1/3 power, that's our outside function. Okay, so that's our f. Okay, I'll just put f there. Alright, so if we were to take the first derivative of this, it's going to be that we have y prime is equal to, and what we're going to do is take this exponent, we're going to consider that. So this is kind of like, some people, even the book, I think it refers to our inside function, our g of x, sometimes as u. So then, again, this is just a notation thing to try to make things simpler. I personally don't prefer this, but some people might, so I'm just going to introduce it here. So in this sense, if you make our inside function look as u, then our chain rule would look like f of u of x is going to equal f prime of u times u prime of x. Okay, so that would be another form of the chain rule. If you'd like to remember it that way, it's basically just replacing our g of x with a u. Okay, so anyways, so if we do this, if we differentiate the outside function, we have something. In this case, it's like our g of x raised to the 1/3 power. Okay, so we're going to bring down that 1/3 in front, 1/3 times g of x, and then if we subtract 1 from the exponent, we have 1/3 minus a 1, okay? And then we're going to multiply this times whatever g prime of x is, okay? Alright, so now, moving along, we have that y prime is equal to 1/3 times g of x, and I'll replace that, so that would be x to the third plus 2, okay, because that was the inside already, alright? And then up on the power, we have a negative 2/3 left, and then we have times the first derivative of the inside, so first derivative would be d dx of the inside, so that's x to the third plus 2, okay? Alright, so again, moving along, we have that y prime is equal to 1/3 times x to the third plus 2, quantity to the negative 2/3 power. Okay, and then we get what is d dx of x to the third plus 2, so the 2 will go away when we differentiate, and according to the power rule, the derivative of x to the third is 3x squared. Okay? Alright, so now we see that this 3 on top cancels with 3 on the bottom, and we are left with, let's see what we have. So we have an x squared on top, so x squared over, and I'll just write it down here, x to the third plus 2 to the 2/3 power. And it's on the bottom because the exponent was negative. Alright, so this in the bottom right corner, this is our y prime. Okay?
The type that makes me feel low.